Welcome to our MGISS webinar today. This is the second in a series of webinars we're running over the next few weeks. And this one's entitled Improving the Accuracy of Field Data Cost Effectively. Now, for those of you who didn't join our first webinar, there'll be a certain element of overlap and some duplication with the slides, but the theme that we've adopted this morning is based on some feedback we've got, and we wanted to dive in a little bit deeper into one of the aspects of mobile GIS that we get asked a lot of questions about, which is around accuracy. So we're going to run through a number of different items this morning. Firstly, welcome to everybody who's joined us. I'll give a quick introduction. And then we're going to consider three elements: accuracy, some of the issues that relate to some of the questions that we get asked around trying to reconcile using GPS equipment or GNSS equipment with existing map data or existing network data. We're also then going to consider some of the solutions that are available, and then alongside that some of the indicative costs. Then we'll summarize. So we have actually been receiving questions, so we don't take live questions, but what we tend to do is then steer our next seminar theme based on the typical questions that we've got asked. So we posed a question really to ourselves, but again it's been based on questions that we often get asked by customers and people that we work with. So very often people are finding that either their existing asset records are not mapped correctly, or perhaps not mapped accurately enough. And sometimes you only find this out when you've revisited an asset or you need to undertake any work or relocate it for some other means. First question is around trying to determine which asset you need to inspect or visit or get to on the ground. So when you've got a number of different items or a number of different things that you need to visit and they're closely spaced, trying to determine which asset it is, it can be quite difficult at times. Secondly, how can someone find an asset accurately if it's buried? And it could have been buried such as a service, an underground service, or it could have been buried over time. Say an overgrown site or something like that. But one of the questions sort of more pertinently we get asked is when you're trying to reconcile existing network data on a map, people often say, why is the map wrong? So there's an automatic blame assigned, and there's obviously a lot of background to that, and this isn't meant to be a blame exercise. It's trying to sort of find out ways in which we can understand if there's an error, why the error exists, and what steps we can take to overcome it. So just to give a few examples of assets, and assets mean different things to different people. But when you've got situations like those illustrated in the slide, such as an overhead network which is closely congested, or a woodland within which you might need to find a specific tree, or even a site such as one at the bottom where you've got an overgrown site but you're trying to find a specific location on that site. These are typical real-world situations that people find themselves in, wanting to find ways that they can use handheld GPS systems to navigate their way to the correct place. Similarly, this is a slide that we used in the last seminar, and people found it quite useful. But when you're trying to locate something which is buried underground, particularly in more congested urban areas, then part of our role and our advice is trying to determine, if you're working with a specific range of accuracies, then you're only going to be able to find an asset to a specific level. And we'll come on to this a bit later in the presentation. But just to give a bit of background, and again, it's surprising how often this is the case, that people don't really understand from a historical point of view why inaccuracies exist, particularly when organisations such as Ordnance Survey, who are our national mapping agency, are using sort of high-grade surveying and GNSS equipment to update or make changes to the maps. But when you've got an organisation which is, you know, over 250 odd years old, and the fact that a lot of the UK was mapped at different scales using surveying methods, this is why we find today that errors exist. And it's just to give a bit of background to that these next slides are going to explain. So within Ordnance Survey mapping, there are 4 accuracy categories, or 4 different scales at which data was originally surveyed. We have a 1250 scale, which was predominantly used in the urban areas to map obviously built up landscapes. We also have a 1 to 2500 scale, and there's two elements to this. One which was the original survey, and one which was based on the old county series maps that were overhauled in recent decades. And then we move out to the 1 to 10,000 scale, which typically was used to map rural and moorland areas, of which there obviously are a lot of in the UK. And from an Ordnance Survey perspective, accuracy can be described using 2 definitions. One is absolute and one is relative accuracy, and I'll explain the differences between the two. So when we talk about absolute accuracy, and this is a more familiar term for those who are using GNSS or GPS equipment in the field, absolute accuracy is a measure which indicates how closely the coordinates of a point on the map, such as Ordnance Survey, agrees with something which is being captured in real time on the ground using GPS. So that can give you an indication of the absolute accuracy of a point that's being captured. However, when we talk about relative accuracy, what we mean by this is that relative accuracy compares the distance between features measured in the real world to their equivalent on the map. So a good way of describing relative accuracy is when you're plotting the position of a new water main or a new tree on the ground, for instance. Now again, this is just a very quick illustration of the situation in the UK we have, where according to those different scales, 1250, 2500 and 10,000 scale, you can see within this part of central UK the areas that were mapped at those scales. So 1250 scale relates to urban areas, 2500 scale relates to the majority of the remainder of the UK, and then we have 10,000 scale, which relates to the mountain and moorland areas. So Ordnance Survey quote accuracy levels that they adhere to within those scales, and you can see within the urban environment, a 1250 scale, they quote an RMSE accuracy of 0.5 meter. So what that means is that you could expect that any point mapped on a 1250 map to be as error prone, I guess, as plus or minus 0.5 meter from its real world value. And then we move down through 2500 and 10,000 scale, and you can see here that the inherent accuracy within maps at these scales increases to about 4 meters, and again, that's a statistic that's quoted by Ordnance Survey. In the real world, you can find it can be better or worse than this, but you always need to be mindful that this is what the maps originally were mapped to. And with relative accuracy, they deal with a similar statistic, but over a measured distance. So again, as an example, you've got the 1250 scale, the urban areas, a relative error, again, of plus or minus 0.5 meter. over a measured distance of 60 meters. And I think this again relates to the use or the depiction of asset layers on top of something like a 1250 map in an urban area. And then again we move down the scales and you can see the relative accuracies move out. So it's important to consider this when you're trying to reconcile using mobile GIS or handheld GNSS equipment in conjunction with map data in the field. Again, just to give an illustration of this, what you can see on this slide is a section of Ordnance Survey master map data, which is their large-scale topography layer data, typically what you would see in an urban area. You've got a street and a highway, and within that highway, somebody like a water authority might have existing network data layered on top of the Ordnance Survey master map data. So what's critical for a water company is to make sure that the position of that water main as it's mapped looks right on the map. And the disparity can often occur where you're working within an inherent error within the map, and you might be using a real high-grade GNSS or surveying technology to capture the whereabouts or the position of a point feature such as a valve, and also a linear feature such as a water main. So you see that within the center of that picture, the absolute position could be quoted as 3 to 5 centimeters. However, when we talk about relative measurement, what we mean is that a surveyor or an inspector on the ground might have captured the as-built position of that water main or that valve using dimensions. So he's relating it to the surrounding detail. And within that relative measurement, the accuracy that you're working with on the map is only 30 to 50 centimeters in reality. So you again need to consider when you're taking dimensions or you're capturing something relatively that you may still always have an error. And when you're combining the two, this is when some of the issues can occur. So we've developed strategies and I guess best practice in order to try and educate those capturing this sort of information or updating this information in the field as to the best way to go about it. So just as a guide to working with these map errors, what we always recommend to existing and prospective clients is that you always need to work to a minimum of map accuracy. So what that means in reality is if you're working in an urban area, you need to be working to a minimum of half a meter, if not sub half a meter, to be within the map accuracy of that 1250 map. Now for network assets in urban areas, you'll predominantly find that because you can reference yourself to surrounding detail such as curtilages, building footprints and so on, that the best and most efficient way of mapping is by using relative measurements, because critically again it's important to make sure that the asset you're mapping is looks right on the map, so it's shown in the road or in the verge as opposed to the other way around. But when there's insufficient detail to be able to map using such as urban detail, then what you need to rely on more is an absolute position in rural areas. So that generally brings into the fold the use of GPS or GNSS instrumentation. So when you're mapping cross-country pipelines, or when you're needing to use something other than a map reference, then GPS and GNSS equipment, surveying equipment, comes into its own. But again, critically, the asset ideally needs to be shown correctly on the map at all times. So in terms of a recommendation, and specifically for new data capture, and this is something that Ordnance Survey has been adopting for many years now, is you would recommend the use of high accuracy GNSS equipment for capturing new data. So this might be a new development or a new assets that are going into the ground. So you're able to store really high accurate absolute positions for those assets. Now, it may mean that you are generating errors relating that data to the surrounding map. However, it's a recommendation that we would always want to store absolute coordinates and the capture method. So that might be the type of survey instrumentation or some quality information around the position itself. And the reason that this is important, or the reasons that this is important, is that if you're needing to use high accuracy asset positional data for modeling, for relocation, so that's finding an asset over time without the need to dig up the road too aggressively, and also from a data quality point of view, the recommendation is to use the best surveying technology you possibly got access to. So it is about choosing the right tool for the job, and there's obviously a number of different ways that you can look at developing a suitable solution. But more and more we're finding that we're getting asked about which mobile GIS software. So that's an interface for capturing high accuracy GIS information, whether that's fit for purpose. And the way we dictate whether something is fit for purpose is certainly when you are using Ordnance Survey data in the field, is to make sure that when you're capturing GPS information that it's using the most up-to-date Ordnance Survey transformations. So this is taking for instance, a GPS position or a GNSS position in latitude and longitude and height above ellipsoid, and transforming it in real time to the equivalent easting and northing value, and it uses two Ordnance Survey derived projections. One is OSTNO2, which deals with plan accuracy, and the other is OSGMO2, which is the geoid model for the UK. We will be going into detail on this specific requirement in the next seminar. And alongside that, what we adopt a recommendation around is making sure that whatever platform's being used in the field, that in order to use GNSS equipment, it's as simple as plug and play, and understanding how GNSS can be scaled through a number of different accuracies to achieve the accuracy that you want. But alongside that, what we recommend is the capture of quality flags, both in the workflow, the mobile GIS workflow, but also in the database that exists in the back office. And quality information around the method of data capture, the accuracy that was captured in the field, and also some other relevant information. And what this tries to determine is to drive the behavior of field teams. So when you've got a number of different contractors or a number of different operatives working in the field, you want to try and standardize on the way they capture information. And the reality is that this doesn't happen, and we see lots of different data quality issues being raised in the field, just purely because there's no standardization in how you capture information. So I've been talking about GNSS, and in the previous webinar we spoke about GPS, which is the more familiar term, only being one of a number of constellations within the Global Navigation Satellite System Network, which is GNSS. It's an acronym that relates not just to GPS, but all the available constellations of satellites that can be used to compute a position. Making sure that the workflow that you develop is able to also capture the statistical quality of the GNSS position that you're capturing. If, as explained in the previous slide, you're using a combination of absolute and relative measurements, then the method by which you capture manual measurements or dimensions needs to be robust. So in the earlier slide where we were showing the position of a valve on a linear main, you need to make sure that you've got at least two minimum or 2 as a minimum measurements or relative measurements taken from surrounding detail, and that just allows you to better intersect the position of that asset in the real world. And again, the software that you use needs to be suitable to be able to capture both absolute and relative measurements. And then you might also find that you want to integrate other types of sensors into the solution. 2 examples here I've given are the use of a laser rangefinder or a cable locator. The use of a laser rangefinder means that you can take a bearing and distance offset to a GNSS position, and a lot of our customers might have access issues or inability to measure the position of something without using traffic management. So the adoption of using a laser rangefinder within the solution might give efficiency improvements. And similarly, when people are using cable locators to trace buried surfaces, with the integration of a more high accuracy GNSS receiver, it allows you to positionally tag the location of that much more accurately. So it's about finding tools that can integrate or plug and play into these external sensors quite simply. The other consideration is around, in order to achieve various levels of accuracy, you might need to deploy a correction to that GPS or that GNSS signal. And I've got a couple of slides coming up on that. One final note is around not using real-time corrections to a GPS position, but also using a post-processing technique, which allows you to do the data capture and then improve the accuracy of that in a back office environment through a batch process. Okay, so just some consideration around the type of real-time correction services that are available. You'll see in the illustration there the red line around a sort of European North African footprint. There's a service called EGNOS. And EGNOS is one of a number of satellite-based augmentation systems, or SBAS, that are available worldwide. Effectively, it's a band of geostationary satellites that above the Earth broadcast corrections to any compatible GNSS receiver on the ground. It's a free service, so what that means is you can achieve with the right equipment sub-meter down to map accuracy with an EGNOS correction, and you've got full footprints certainly across the UK and Ireland. So we find a lot of our customers now are utilising these free correction services in order to improve the accuracy of the data that they're capturing, or in order to be able to relocate assets further down the line. And that's a free service which is available. There are also a number of real-time correction services which are subscription-based available, both in the UK and worldwide. Those that are more familiar are what we call network VRS, or virtual reference station correction services. There is a network of continuously operating reference stations in the UK, which are owned and operated by Ordnance Survey. They use network VRS in order to get high accuracy data in the field, and us as end users can use one of the third-party services leveraging that VRS network from Trimble, Leica, or Topcom, and that's typically an annual subscription that you would pay in order to receive those corrections and improve the accuracy of your data. There are also a number of satellite-based correction services which are subscription only available, such as Trimble's RTX or Hemisphere's Atlas service. Now, typically, in order to pick up these corrections, you need a suitable piece of GNSS equipment in order to do that, of which there are many on the market, and they usually need a firmware switch or upgrade which allows you to pick up these corrections alongside some software which needs to be compatible. But what all these services can achieve are very accurate real-time GNSS data, typically in the region of 30 centimeters down to 1 centimeter, depending on what type of equipment you use and what level of service you subscribe to. Obviously, with the benefit being convenience, you don't need to set up any additional equipment or post-process your data. On the flip side, there are subscription costs, but these subscription costs themselves, certainly for the satellite correction services, can be monthly, so you can switch the service on and off as and when you need it. So how does that relate to equipment and the type of thing that we as MGISS are finding that we're delivering to our customers? Well, of course, with any mobile GIS solution, there are a number of different components. This slide focuses on the hardware and external sensors and compatibility. But we've got a number of Bluetooth-enabled smart sensors entering the market, which are completely scalable and sort of interoperable with a number of different sensors because of their portability. So receivers such as those from EOS positioning systems, which are the Arrow series, are a series of receivers which allow you to move up the accuracy scales, right from mapping up to survey grade dual frequency. The nice thing about these receivers is that they have a low power Bluetooth, so they're not drawing any power from a peripheral device that you're using, such as a tablet or a smartphone. But you can also integrate these receivers with other types of sensors, even DSLR cameras or cable locators, so you can improve the accuracy of standard data that you're capturing or imagery that you capture in the field. More typically, we have pole-mounted antenna. When you move into the survey grade GNSS requirement, which the image on the right of this slide gives you, you'll see that the receiver in question is a spectral precision receiver, but that's a dual frequency centimeter level GPS receiver. And that can plug into anything from, again, a consumer level tablet to a more ruggedized or a bespoke platform for capturing data. On the left of the screen, we've also got sort of new sensors coming onto the market which allow you to take something like a smartphone, connect a higher accuracy GPS receiver to it, and also link something like a laser rangefinder to the back of the smartphone. So not only are you able to remotely capture a position using the laser rangefinder or capture an image, which, because you know your distance to the target, allows you to take dimensions from that image, but you can also improve the accuracy not only of your local position, i.e. where you're standing, but also that remote position using a plug-and-play GPS receiver. So again, the next webinar will go into more detail about how you can build these solutions to work for you. And then just in terms of the workflow side of things, if you're an asset owner, you have an existing GIS corporate GIS system such as Esri. We're also seeing more open source platforms such as QGIS coming onto the market, which are providing a lower cost of entry. So you've got existing asset data that either could be poorly positioned or might require some data maintenance on it. Even if it is an existing asset which has been positioned to a high accuracy, it still has to have a cyclical inspection regime around it. So it might be an overhead line, for instance, or a water network that you have to go out and inspect over time. So again, the recommendation is that for data capture, or for when you're trying to improve the accuracy of existing assets, then you would want to use as high a level of GPS equipment or GNSS equipment as you possibly can. And on the right hand side of the image, what you can see is you can build a commercially off-the-shelf or custom solution depending on your requirements, and that's typically the end of the market that we find ourselves working within the UK. Other considerations, such as whether you want to send information in real time through the cloud in the field, will determine what type of software platform that you utilize. But then from an asset maintenance or inspection point of view, if the position of those assets is fixed, then you don't need to take a high-grade GPS or GNSS receiver into the field in order to perform an inspection. As long as the workflow standardizes the type of data that's got to be captured, and you can use an onboard GPS receiver such as those you find in a standard smartphone. You'll find you can adequately use those type of devices in order to perform an inspection. And again, the critical aspect of that is making sure that you don't need to relocate or improve the position of that. Other considerations alongside that might be the delivery of that information. You could have a number of different client requirements which might need you to deliver information via a web interface or a dashboard, and also give you some productivity information about your field operatives. So increasingly MGISS are being asked to develop those sorts of applications as an add-on to a more corporate level GIS. And then you might need to pull off specific reports, so it could be needing to allocate a work schedule to a particular defect that you found on site. So the ability to quickly define information around some work that needs carrying out might require you to capture an image, some defect information, and be able to send that back and report it via PDF to a contractor or some operational staff so that they can quickly respond to an incident. So all these considerations are best looked at before you really start to look at mobile GIS. And that's where we as an organisation can help you define what's best for you. And again, this is a slide that we had during the first webinar, and people saw clarity on. So I just thought I'd bring it back up as an indication, really, of what I call a cost curve. But what you'll find in reality is that as you increase the accuracy requirement of a solution, then the cost goes up. Because you've got so many different available solutions and configurations available, it's trying to determine what is best, or what toolbox of equipment is best for your specific requirements and workflow. So just to explain a little bit more about what this slide indicates, you can see that from a GNSS point of view, when you move from consumer level GPS receivers or GNSS receivers through to the mapping grade receivers, you're generally looking at a sub-meter capability costing you in the region of £2,000 to £2,500, and that could either be an all-in-one handheld or a plug-and-play Bluetooth receiver. Then you need to factor in the requirement for software, which again, if you're looking at more of the cloud type solutions that are available, annual costs are typically around £300 or £15 to £20 per month per user. More traditional or disconnected type software platforms utilize a license or a subscription, a one-off subscription with some annual maintenance, and typically the costs of mapping and surveying software vary between £750 to £2,000 depending on your specific requirements. So as you move more into surveying platforms, typical license costs are at the upper end of that level. And then as you move up the cost curve into more centimeter level surveying requirements, then you'll see that the cost starts to increase to the point where you're looking at £8,000 to £9,000 for a fully integrated GNSS system with some real-time correction service being deployed. The one I've not mentioned are these all-in-one systems which are coming on the market, which integrate GPS receivers, laser rangefinders, and software into a handheld platform. These are quite scalable in terms of their accuracy capability, and typically costs are in the region of £5,000 to £7,000. But we're finding that the more scalable solutions, plug-and-play solutions such as the Arrow receivers or the Trimble R1 or the mobile mapper receivers are meeting the needs of the majority of our customers across infrastructure, utility and environment applications. So this is more and more what we're finding are being recommended either as plug and play into a piece of software that you might already have, or as part of a solution that we deliver to you. So all I wanted to do now is just come back to this sort of first slide again. So when we start to look at the accuracy that you need to position an asset, when you consider the difference between 10 centimeter accuracy and something like 60 centimeter accuracy, you'll see that circle could, if you were using the latter of the two, might position an asset in the road as opposed to in the footpath. So again, when you're determining what you need, this can dictate what type of accuracy level and hence solution that you need to look at investing in. Again, when you start to look at other map accuracies or moving down the accuracy scale, you're obviously reducing the cost, but you're also reducing the efficiency of the measurement that you're capturing, right out to what we class as consumer level. And that is the question really: how accurate do you need to be when you consider all the other factors that we've briefly gone through in the slides? You know, very often the question comes back, well, what can we achieve for X number of pounds? And if it's a budget constraint, then again, that's something that we can help you provide some business case around. And that's really, as a summary, what I wanted to come back to this morning with you is understanding, you know, some of the issues that exist around reconciling existing mapping, legacy mapping, and existing asset data alongside the use of something like GNSS equipment. So we take you through a journey by understanding your requirements. We certainly provide independent advice. So it's not whole of market, but what that means is that we've, through our own experience and through, I guess, you know, long usage of this type of equipment and research around the technology that's available, trying to give you the most cost-effective approach. And cost-effective can mean different things to different people. But from our point of view, and then certainly working with you, building a business case for investment in this type of technology, it's about reducing your risk and making sure that we're defining a return on investment that certainly from our point of view, you'll get a full return on investment sometimes within a single project. But it's not just about delivering a solution, it's also about supporting you throughout the whole project. So we do provide independent consultancy. We certainly look to build solutions, and we have full sales, service training and ongoing support for anything that we deliver. And we're trying to do more of these events. So, you know, again, based on the feedback that we get and the questions that you pose to us, you know, we find this as a good medium for trying to provide you with tools that might give you the right sort of advice you need to build a business case. We will have another webinar scheduled in March, and we're also then sort of linking this with a number of different product and service promotions that you as attendees this morning will have priority access to. So if you do have any questions about what you would like to hear in the future, how we can maybe better improve the delivery of these webinars, then we're more than happy to take advice and steer the type of information that we deliver going forward. Certainly, if you want to see any of this technology in place and working alongside your required workflow, then that's something that we would be happy to discuss with you as well. So we've come to the end of today's webinar, and lots of different ways that you can contact us as an organisation, and certainly me individually, using any of the details you can see on the slide. I'd like to thank you for listening in this morning. I hope it's been useful. I hope I've not sketched over things too quickly, but certainly, more than happy to dive into any elements of that going forward. So thank you again, and have a good day.